And for the last 5 years, I would say, there's been a troubling movement in transmitters. 2.4 gigahertz is a leap forward in every way but one. And that one problem that 2.4 gigahertz has is it will not penetrate water. I've personally experienced a Spectrum 2.4 gigahertz radio installed in a Dumas Blueback where it was a joy to run only because the failsafe kicked in and released itself so fast that you couldn't really tell that it was the failsafe that was kicking in as the submarine porpoised its way around the lake. Because that submarine, when we were testing it, you could literally hold it 3 inches below the surface with the deck taken off so that you could actually see the light on the receiver. And holding that submarine 3 inches below the surface, you could see the failsafe kick in. So you had literally about 2.5 inches of water penetration. And this was not the cheap entry-level Spectrum. This was a 7-channel Spectrum that was the top of the line at the time. We're talking 10 years ago. So we in the submarine community have been at an impasse. Fewer and fewer manufacturers are building 75 megahertz or 50 megahertz, or if we're talking the European Roby and Graupner machines, those are 35 and 40 megahertz. But the entire industry as a group is moving toward 2.4 gigahertz because the benefits to everybody else on the planet are astronomical. You get built-in failsafe. You get a digital connection from the transmitter to the receiver. You get the same type of protocol that they use on Wi-Fi routers where one receiver will only talk to one transmitter no matter how saturated that channel is with other crosstalk from other transmitters. You have that binding that is so much the bane of people who don't know how to bind. But the point here is I don't know of an actual manufacturer who actually makes a computerized radio anymore that doesn't transmit on 2.4 gigahertz. You can buy a 6-channel transmitter, a 7-channel transmitter, an 8-channel. You can buy all, if you wanted to spend $3,000, you could buy an 18-channel transmitter. The problem is that 18-channel transmitter is only going to transmit on 2.4 gigahertz. I know of the Futaba 4-channel, 75 megahertz, and that is it as far as what you can buy brand new from a reputable distributor. There is no other manufacturer that I know of that still literally displays on their website a 75 megahertz transmitter. Even the ones that Caswell is selling right now, the WFly 8-channel and WFly 6-channel, if you go to WFly's website, the actual Chinese manufacturer of those radios, they, on their website, no longer have any information about anything but 2.4 gigahertz radios. And that's just in the last 6 months. If you had gone to their website last year, December of 2013, they still made a 6-channel radio that had, or an 8-channel radio that had the module that clipped into the back, and you could take the 2.4 gigahertz module that it shipped with and replace it with a 75 megahertz module. Well, that generation of transmitter was replaced about 6 months ago, and the new generation of radio that's on their website, that is no longer a modular radio. It just has the 2.4 gigahertz antenna directly mounted on the transmitter. So we are at a serious crossroads here. We have to find something out there that will allow us to still penetrate the water, but I mean, it's even still it's getting hard to find 75 megahertz modules for the radios. You can find these radios used on eBay for as little as $100. But the last time I saw a 75 megahertz synthesized module on eBay, the guy wanted over $150 for it because he knows that these are a hot commodity. Well, what I have discovered is a guy from Turkey who has his own website called flytron.com is making these. And what these are is his ambition is to make a quadcopter that he can use with his first-person goggles and fly more than 20 kilometers away. And the way he has done that is he has designed his own circuit board that he has placed the specifications to out in the public domain under open source licensing, and the software that he wrote for that in the same fashion. And basically what this is a small little microprocessor that's been programmed to look to development environments as the same microprocessor, what's called in the community, the self-making community, the MakerBot community, as an Arduino. And he's tacked a RF deck onto the back of that. And this transmits in the 433 megahertz range. In the United States, the 433 megahertz range is a ham frequency range. So in order to use this legally, you have to go down to your local, do a Google search and find out where your local ham club is, hand them $15 and take a 35 question multiple choice test and get 28 or 27 of those 35 questions right. You can only miss 8 questions. And these are some pretty, for anybody who has two weekends to cram for the exam, it's pretty easy to pass. I think I missed 7. So if I can do it, anybody can. It's $15 and that's a lifetime. You never have to take the exam again. And the kind of questions that I had to answer were questions like, if you're working on an antenna, how far away from a power pole do you have to be in order to be safe? And the answer to that question is, well, if the antenna is 15 feet tall, you need to be 15 feet away from the power pole. Or here's a diagram of a circuit. What is object number 4? And they've got 6 objects on this diagram numbered, and in my example, object number 4 was a resistor. So if you can read a circuit diagram and answer some pretty stupid questions, you probably will pass your exam as well. And there are tests online? Well, yeah, there's a really good online place that I crammed for, and it basically has all of the questions that were ever asked in the 2010 to 2012 time frame. So you're actually taking real 2-year-old tests and being graded on them. And I basically, over a 2-week period, took that test probably 100 times until I could guarantee every time I went through the test I got less than 7 wrong. And then I called up, there was a ham club about 15 miles down the road from where I live, and they meet at their local library every 4th Saturday, and at least 2 of the club members at that meeting are guaranteed to be certified instructors. So I handed them the $15, took my test, and a few weeks later I got an envelope in the mail with my license. And I'll never have to take that test ever again. And because of that, I get to play with things like this, and there's another 50 megahertz frequency range that allows us to use something other than 75, but those transmitter modules for these types of radios are even rarer than the 75 megahertz stuff, so that's not really going to help us any. But there's a distinct advantage to using these, and these are built upon the same types of concepts that the 2.4 gigahertz stuff has. There's no distinct frequency that you have to use a frequency board. It's just like the 2.4. I can choose anywhere from 3 to 24 frequencies that it hops between. I can pick what those exact frequencies are that it hops between. I can pick anywhere from 8 proportional channels to 16 proportional channels that just don't have the range that the 8 would. Or I can mix, I can have 8 proportional channels and 4 on-off channels. all kinds of wonderful things that you can do with this actual application that runs on a Chrome browser as a plug-in for that Chrome browser. And you basically you have a circuit board that plugs into these pins and has a USB cable coming out the other side, and you basically program this just like you would be programming one of your speed controllers. And there's about 20 different settings that you can vary on these things. And then you bind this to your receiver, and then you plug this into the configurator and press the little connect button for the receiver, and then you've got 30 seconds to turn on your receiver, and then you basically have a channel from the transmitter to the receiver in which you can set about 10 different configurations on the receiver, including things like what the fail-safe positions are for all of your servos on your submarine, and what the delay time frame is between when you lose signal and when that fail-safe actually kicks in. Because let's face it, you don't want that fail-safe kicking in on the very first little dropout. So I've got this guy set up so that he will not kick in the fail-safe until 5 seconds after his signal has been lost. Now, because it is open source software, I can actually go in there and change the code so that, let's say we want the throttle fail-safe to kick in immediately or within a 1 second delay, so that we're not hunting for a submarine that's halfway across the lake when the final fail-safe for the ballast tank actually kicks in, and we're actually seeing our submarine surface, because when we lost signal, we were at full throttle. But that's the cool thing about this. I can download the software off of GitHub and compile it and download it just like I'm playing with a little Arduino microprocessor. The other thing that I've worked on, and this is my personal, as Tom Chalfant has said, I'm like a mad scientist. And one of the things I did that has been is now available to me because of the 4.3 megahertz with its little stubby antenna, or 433 megahertz. I built this wonderful little contraption that clips onto the back of my tablet. So I've got a glass cockpit for my submarine now. And I've got a touch screen that allows me to have a user configurable screen that can vary from one submarine to the next, depending upon what controls I have available for which submarine, and where I want to have my thumbs on the display when I'm actually running the submarine around. And it all cost me about $40 to pull this off, plus the tablet, plus all of the development time on the software. But basically what this is a piece of software that communicates via USB to a small USB stick made by a company in Boulder, Colorado called Mile High Wings. And the whole purpose of this little stick is to output a PPM signal to this module, just like a normal transmitter would. There's one limitation, and that is this little stick will only generate an 8-channel signal. So if I'm using less than 8 channels, I just don't plug them in on the receiver. If I need more than 8 channels, well, I'm kind of out of luck. But this is my little mad scientist extension beyond the standard 433. This is just a little dream that I've had for the last couple of years. And it wasn't this is actually a Windows 8.1 tablet that I'm running this on. But I hope when my final revision of the software is done that I'll have versions for both Windows 8.1 and Android. And if there ever becomes a need for a Linux tablet, then I'll probably write the software for that as well. It costs too much money to do it for the Apple devices. For me to actually run my own software on my own Apple device, I have to pay Apple $99 a year. It's free to do it on Android, and it's free to do it on Windows, and it's free to do it on Linux. One possible scenario that I'm still investigating is the same group of fanatics out there that came up with the OpenLRS stuff are There's a small subset of those guys that are programming their own Arduino devices to generate that PPM signal. And if I go that route, then I will no longer be limited to just 8 channels. The sky's the limit on that. I could probably do 16 to 18 channels with no problem. But who needs 18 channels, right? So that's it. That's pretty much all that I have to say this evening. If you've got any questions or comments, now's the time.
Have we found the penetration?
Okay, that is one thing I did want to cover. That's one of the things that you can configure. This transmitter module and this transmitter module are both sold as 100 milliwatt modules. They make the 100 milliwatt and they make a more advanced, more powerful one that's listed as a 1 watt module, but it really maxes out at about 850 milliwatts. But in the configuration tool, you have 8 possible settings with value number 8 being the maximum. This one right now is set at value setting number 3, that if you look up in the chart, that means this guy's putting out about 6 milliwatts, which is actually even below what the European 2.4 gigahertz modules are limited. They're limited to 10 milliwatts for reasons unknown. But the fact that this guy can still work on 6 milliwatts is amazing. And I actually have video of the Delta in my clubhouse swimming pool sitting on the bottom 8 feet below the surface, still under full control. And we're talking about a chlorinated swimming pool. So that's, besides salt water, that's about as bad as you can get. And that's on the 6 milliwatt setting. I've also ran it in a very nice pond that is a really great model submarine running venue up in what we call Superior, Colorado, which is like halfway between Denver and Boulder. And same situation, 6 milliwatts, 100 feet away, 6 feet below the surface, still under total control.
Okay.
So the penetration, I would say, is as good as your 75 megahertz gear. Okay. And that's one of the things that I would love to bring up here. If anybody has $25 that they can spend on Hobby King for the transmitter module, and $20 that they can spend for, actually I think it's less than $20 for the receiver. These are drop-in replacements for the 75 megahertz gear that you already have. This is a Futaba form factor. They also have them in a JR form factor case for the JR radios, like the 9303. And then there's a third deluxe model that Hobby King doesn't carry, but Flytron does, and it's a $99 module that plugs into the trainer port on any transmitter that has a trainer port. And they all come with, I shouldn't say that, actually the Hobby King all come with this style of antenna, which for the open LRS FPV guys is they all claim this is utter crap. But for me, it works flawlessly, and in fact, this works flawlessly. If you want to take a look, I've got basically the same exact antenna in the Delta right now, except it's got a little 90-degree bend, so instead of sticking straight out, it sticks out to the side. But the little tiny, this was $1.50 on eBay. This is what it came with. If you buy, there's 4 or 5 websites that will sell you this Hawkeye brand, which is the actual original manufacturer. There's a new guy out there called DTF UHF, and the DTF UHF model is the $99 deluxe model. Hobby King sells them for 20 bucks a pop and 25 bucks a pop. The other sources, the transmitter modules, are $60 for the standard, $100 for the deluxe, and $39 for the receiver. And based on the testing I've done, I've got 1 of the Hawkeye receivers and 2 of the Open LRS Orange RX Hobby King receivers, and a 1 watt and a 100 watt Orange Hobby King they're all interchangeable. I can reconfigure them with the same exact tool. The very first thing, it's kind of like a throwback to the Heathkit days. You're not actually soldering components. They come assembled, but there is programming. You have to download and install the latest generation software if you want to have that configurability. Off the shelf, the OpenLRS products from Hobby King do come with basically, I think it's like version 0.9 of the original software. And the current generation software is it's actually labeled as OpenLRS NG, and it's up to like version 3.6. So we're talking like 2011 era technology on the original software installed on these guys. And it will work out of the box, but it's hard-coded with a binding ID, so no matter what you do with the transmitter, every receiver and every transmitter module you buy from Hobby King will bind to each other. And it's basically whoever turns on their transmitter last gets control of the receiver. So you want to upgrade these guys to the latest OpenLRS NG software the day you get it, unless you plan on running one submarine by yourself with nobody else with one of these in their submarine. And I just think that's bad form. So you want to buy this from Hobby King. You want to download your Chrome web browser. You want to download your OpenLRS NG configurator plugin. And you want to buy, it's actually called an FTDI programming board. And it actually plugs into these pins here and plugs in, has the cable on the other side that plugs into your USB port. And I actually have one here with me that I can show you later on, but it takes me about 20 seconds to upgrade the software from the factory. So it's not a huge problem, but it is a significant, important step to do. And everybody that sells these basically says this is not a plug and play arrangement. You do have to do some configuration. But I see that as a potential for having much more power. You can do, one other thing that I forgot to mention about these is they actually are transceivers. So one of the things that you can configure for these is what they call telemetry mode. Telemetry mode basically means that you can send data from the receiver back to the transmitter. And the types of telemetry data that you can send back are your battery power, how much life do you have in the battery on your submarine. You can get, literally any of the sensors that you can find on these little MakerBot websites that can be plugged into an Arduino can be plugged into this receiver. You can either plug them into an Arduino and then plug the Arduino into the receiver, or there's a whole plethora of devices that they've made for the FPV quadcopter world, like GPS sensors, a lot of stuff that really doesn't penetrate water any better than 2.4 does. But there's a few things I've investigated, and we can get battery voltage and amperage. We can get motor temperature. We can get motor RPM. We can get a magnetic compass. And we can actually buy a pitot tube that is designed off the shelf for a model airplane, but with a plastic membrane, like basically a rubber balloon stuck over the hole. You can turn that pitot tube into a waterproof device that will give you the water speed of the submarine. And those are all pieces of information that can be sent from the submarine while it's 3 feet below the surface, running in circles while you're nice and dry on shore. That's another one of the mad scientist things that I hope to incorporate into the glass cockpit. But those are down the road. We'll give you updates as those things either pass into fruition or die on the vine. But that's what I have for future technology, and I see a huge amount of potential in these two devices here. The fact that these are plug and play with existing transmitters makes them a no-brainer. You spend $15 on your technician's license, you spend under $50 on the Hobby King products, and in half an hour, you have a system that you can live with, that's been around for a minimum of 3 years, and I see being a fad, but a fad that's growing enough momentum that it could be around for decades. And it could be our savior and replacement for the 75 megahertz equipment. That's it. That's all I got.
So I actually have an interesting question, which is, on the quadcopters, they have really tightly coupled accelerometers,
Yes.
right?
Yes.
So you actually have basically a full function gyroscope.
Yes. And one of the things you can do with this receiver in the configuration tool is the product you're talking about is actually what they call an autopilot. And it has either a 6-axis or a 9-axis gyro, minimum. Most of them, in addition to that, have an altimeter and a GPS device. And all of those sensors are feeding into one microprocessor that is then mixing with the signal coming from the receiver and moving either the speed controls or the servos on the aircraft. And one of the configurations that you can set up on this device is, instead of outputting individual PWM signals for an individual servo off the 8 sets of pins, is you can actually configure this so instead of sending out a single PWM, it sends out all 8 channels encoded in what's called a PPM signal off of one set of pins into that autopilot. So you don't have this giant wad of wires sitting between your receiver and your autopilot. You have your 8 wires coming off your autopilot, and that's it. And that was one of the design goals that the original designer had, is he wanted to get rid of that rat's nest of components. He's got a nice little compact FPV quadcopter that has 4 6-inch blades and a chassis that's only 9 inches long. And when you look at that chassis, he's got one circuit board that is the receiver, another circuit board that's not much larger than this that is the autopilot, and stuck to the autopilot is the GPS antenna. And then he's got 4 wires leading off of that to the 4 speed controllers next to the motors. So it's a much cleaner setup in his environment than what you normally find in a traditional 2.4 gigahertz setup.
So my thought with the gyro is potentially like for the axis control.
Yeah, I can very much envision having a monster pitch controller that keeps just like the 3-axis gyros do for a helicopter, we could have a 3-axis gyro for our submarine very easily. That would, connect to the X-tail and the forward diving planes, and your X-tail could be set up to work separately, left side, right side, top, bottom. Each one is, you got basically 4 servos running that X-tail and 2 servos running the left side and right side on your forward diving planes. And as long as you've got forward momentum, that thing is rock solid. Yeah, the future potential here is outrageous. And we're stealing this all from the quadcopter guys.